Hello, dear students. After learning basics of Moore and Mealy machine in previous two videos, let's develop a Moore machine now. Now, this Moore machine that we are developing will take an input which is made up of small a and b. That means sigma in our problem. The input symbols are going to be a comma b. Okay, any string made up of a b will be given at the input. But the output produced by this Moore machine will be capital A, as you see. If the input ends with double A, that means the last two letters of the input should be small a followed by small a, whereas the output produced should be B. If the input ends with two B's, that means last two letters should be small b followed by a small b. But for any other input which ends with anything other than AA and BB or BB should output C. What am I talking about is, let's say that this black box, this box is the Moore machine we are developing for the given problem. And you know the input is made up of small a comma b. This is sigma in our problem. Now, what if we give input like this, A, B, A, B? Now, notice that the input ends with A, B here. The question asked is that if the input ends with double A, then output capital A. If the input ends with double B, output capital B. Otherwise, output C. So, the ultimate output of this Moore machine should be C. Whereas, if we give the input like this, A, B, A, A, now the input ends with double A, so the output has to be A. Whereas if we give the input as maybe A, B, B, A, B, B, now notice the last two symbols in the input are double B, so the output produced should be B. I hope this is clear. And I have already come up with the answer. Before making this video, I thought that I can actually construct the Moore machine. I know it won't be a great experience. I should have shown the development of this Moore machine, but don't worry, in the coming videos we will see that. Now, what is the idea over here, is that if the input ends with double A, so from Q0, we will trace a path that if Q0 reads A, look, this first A followed by the second A, then we can expect that the input ends with two A's and immediately in the Q2 state, we are producing capital A. So you tell me if the input given is only double A, this is the input. Yes, ideal condition, isn't it? Ideal case. Why not? This can be the input, isn't it? Double A. If the input given is double A, then the machine will first traverse due to first A to Q1 and due to second A to Q2. And when the machine is in Q2, it will produce capital A. And indeed, that was the problem, that if the input ends with two A's, then the output should be capital A. What if we give double B? The same idea we have used. On tracing first B, Q0 will go to Q3, and on tracing second B, consecutive B, it will go to Q4, and in Q4 will produce the output B. Isn't it so? So the basic FSM that we have till now got is Q0 on reading first A goes to Q1, on reading second A goes to Q2, and Q2 produces A. Don't worry, we will put the output symbols for Q1 and Q0 also. And on reading B, machine goes to Q3, and on reading another B, consecutive B, machine goes to Q4 and produces B. Now you tell me, isn't it only a matter of filling in the blanks? The blanks are, we have told what Q0 should do on reading A, correct? What Q0 should do on reading B, correct? That means we have finished the discussion of Q0. Q0 now knows what to do on both the inputs A comma B. Come on, you know these rules about FSM, finite state machines, that if there are two symbols in the input A comma B, then every state should have these transitions on A and on B. So Q0, the discussion of Q0 is over, and we know what Q0 will do on reading A and B. What should be the output? Remember, output is associated with every state in Moore machine. Now, come on, this is just the beginning, isn't it? Just the beginning of the machine. So we should say that the output should be C, because at this time, the input doesn't end with AA, neither it ends with BB. I hope you are understanding. But then what should be output produced in Q1? Now, when do you reach Q1? You reach Q1 after reading 1A. But we are searching for consecutive A's, 2A's. So output produced by Q1 is also C. What should be output produced by Q3? We have read only one B, but we are searching for consecutive B's. So the output produced here also should be C. Okay. Now fill in the blanks, fill in the blanks. Do you know what Q0 does on reading A? Yes, you know. It goes to Q1. Do you know what Q0 does on reading B? Yes, you know. It goes to Q3. Do you know what Q1 does on reading A? Yes, of course, you know this. Q1 on reading A goes to Q2 as you see in the picture. But what does Q1 do on reading a B? Isn't it? This has to be defined, and it is so easy to see that Q1 on reading a B can go to Q3. Why? Why really? Because after this current B that we have read, there can be second B. So B followed by B will produce the output capital B. Isn't it so? Okay, let's fill in the blanks. By the way, Q1 is now finished. Q1 knows on A, Q1 knows on B what to do. Let's ask Q2, what do you do on reading A? It's very easy to put a loop here because if we are in Q2, we are sure we have read two A's. And what if that two A's are followed by one more A? That means the input is A. Come on, this also ends with A. By the way, at the second A itself, the machine was in Q2. And due to third A, we definitely have the last two letters as A. So let the machine be in Q2. But what does Q2 do on reading a B? It's very easy again to put this transition B to Q3 because this B might be followed by another B, isn't it? Another B which will take us to Q4. So we will have consecutive Bs. Okay, so Q2 discussion is over. Now, what about Q3? Let's see. Q3 on reading A, what it should do? It's again easy to see that Q3 on reading A should go to Q1. Why? Because after going to Q1 on reading A, who knows after that A there is another A that will take us to Q2. So we have got two consecutive A's and we will be in Q2 state. What will Q3 do on reading a B? Q3 on reading a B is already defined. It goes to Q4 state. So discussion of Q3 is also over. Okay. Now only state remaining is Q4. What will Q4 do on reading A? Just see that Q4 on reading A, can go to Q1 because this A might be followed by another A. And Q4 on reading B will remain in Q4 because B is followed by B. That's why we are in Q4. And then if there are more number of small B's, string still ends with two B's, isn't it? So this is the FSM that we have got. You see, FSM gets built automatically even if we are building it manually. We will first trace the smallest paths. We started with AA and BB, and we knew once we finished with two A's and two B's, we knew that these many states will be there in our Moore machine. That is Q0, Q1, Q2, Q3, Q4. It's only a matter of then filling the missing transitions. And missing transitions should be filled in such a way that correct output will be produced. Okay, give me some time. I'll just erase a few things over here so that we can see working of this Moore machine with some input. Take some input. Purposely, we will take an input which ends with two A's. Okay. Let's see. Let's say that the we are taking, input we are taking is A, B, A. Now notice the last two letters are AA. So the output should be capital A. Machine will be initially in Q0 state. Okay. Now you tell me if the machine is already in Q0 state, notice here the output produced is directly C. So the first output produced is C. Now Q0 reads small a. On reading small a, it is clearly observed that it goes to Q1. Okay, so the new state is Q1. But as soon as machine enters Q1, it again produces output C. Check the output in the Q1 state. Now Q1 is reading small b. If it reads small b, notice this transition, it goes to Q3 state. Machine goes to Q3 state, and in the Q3 state, again the output is C. But in Q3, the machine reads small a. On reading small a, machine goes to Q1. So the new state now is Q1. But if the machine is in Q1 state, it produces C. Now, finally, Q1 is reading A. Notice if Q1 reads A, machine enters Q2 state. And once the machine is in Q2 state, it produces output A. And notice that the input is finished. Input is over. Machine will halt, but main thing is the output produced over here is A. You would ask, what about these outputs? What about these outputs? Okay, these outputs are also produced, but the final output is A. And the question said that output should be A if the string ended with double A. I hope these things are becoming more and more clearer. Okay, let's run the machine once again with some other input. Let's see. Give me some time, I'll just erase a few things over here. Now, what if the input taken ends with two B's? Suppose the input is, let's say, A, B, B, and B. Now watch that this input ends with two B's. So the output produced should be capital B. Machine starts in Q0, but in Q0 it produces output C. Q0 now reads A. On reading A, machine enters Q1 state. But Q1 state produces output C. Q1 now reads B. If Q1 reads B, it goes to Q3 state. Please keep checking the diagram above. In Q3 state, output produced is C. Q3 now reads B. If Q3 reads B, it enters Q4 state. And Q4 produces capital B. But then Q4 now reads the remaining B and it remains in Q4 state. But if the machine is in Q4 state, it produces output B. Now notice the string of outputs here. But the most important output for us is the last output B, which confirms that the input ends with double B. I hope these things are clear. You can check this machine with the input, say AB, AB. You just check it. And the last output produced due to AB, AB will be capital C, which shows that input neither ends with two A's nor with two B's. Similar examples will be taken in the coming videos even for Mealy machines. Thank you very much.